Good day, welcome to chemistry class. I will be your chemistry instructor today. Today we are looking at one of the most important topic in chemistry, and it's very important because if you don't have the understanding of this topic, you may not be able to understand the entire scope of chemistry. Today we are looking at the concept of periodic table. Periodic table actually shows the arrangement of known elements, either naturally occurring elements or synthesized elements in the world. And then let's get started. At the end of this lesson, you should be able to, number one, discuss briefly the history of periodic table. There's a background history of periodic table. How do they come about crafting out and giving us a structured arrangement of elements? And then you must be able to know the law that backs up the arrangement of elements in the periodic table. Elements are not just arranged. There's a law, there's a guiding principle, and this is what we're going to extensively deal with today. Also, at the end of this lesson, you should be able to identify the element in the periodic table. The identification is very important because by the time we begin to do chemical combination and go on looking at different aspects of quantitative and qualitative analysis, you're going to need the understanding and the identification of the element, how they are positioned, why they are positioned, and this is very important. At the end of this lesson, you should be able to distinguish between the groups and the period. When you look at, I'm going to show you the way the periodic table is structured, is into groups and into periods, and I'm going to differentiate between this particular arrangement. Then at the end of this lesson, you, at least looking at this module, should be able to arrange the first 20 elements into groups and periods. Before you begin to talk about their chemical properties, their physical properties, you need to be able to arrange them. The ability to arrange them will give you a foresight of what their chemical properties or physical properties is going to be. And then at the end, you should be able to explain the basic physical and chemical properties of this element, because chemistry, we are very concerned with the chemical reactivity of every known element. So as you start, by way of definition, what is periodic table? This is where you must actually pay attention, because if you don't know by way of definition, you may not be able to have extensive knowledge and understanding of this concept. So the periodic table is a table of the chemical element in which the elements are arranged in order of atomic number. Please note, in order of atomic number. So the atomic number is the basis of the arrangement of elements in the periodic table. Then these elements are arranged in such a way that the periodic properties of the element are made very clear and are arranged accordingly. Now, elements generally are grouped into periods and into elements are grouped into both groups and periods, vertically and horizontally. Now, if you look at a periodic table, then you're going to understand that the arrangement here will give you the foresight of what the property of each of these elements will be. Now let's go further. Let's go further. If you look at it, look at this table that you are seeing. Look at this table. You see that elements are arranged in different colors, in columns and in groups, in horizontally and vertically. Now you must understand that, number one, there are about 118 known, discovered and synthesized elements in the world. 98 of them occur naturally, while the rest are synthesized, especially the 99 and the 109 in chemistry laboratory. And I'm going to tell you why. So looking at the periodic table generally, you have groups and period. Now, the first group is called alkyl metals. The second group is called alkaline earth metals. The third group is called the metalloid, and I'm going to tell you why they are metalloid. You see this element after group 2, you see elements in yellow color. These are called transition metals. They are called transition metal because they are, when you are looking at their electronic configuration, the electron enters into the d orbital. That's why we call them d block elements. They are called d block elements because when you begin to distribute the electron in their shell, in their degenerate shell, you're going to discover that electron is going to come off from s orbital into p orbital into d orbital. So when any element that has electron in its d orbital is called transition element. Then we have the noble gases. Before then we have the halogen. Halogen are group 7 element, and then the last group is called the noble gases. Now I want you to know the arrangements. Now you need to, by yourself, you should be able to arrange the first 20 elements in the periodic table without stress, because this is where chemistry begins. If you don't know how to arrange these elements, you may not be able to work with them when you go on for further chemical analysis. So the first 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Let's take them one by one. Now, having known the first 20 elements, what you must know first is what is the atomic number of this element. If you don't know the atomic number, you may not be able to place them strategically on the periodic table. Now, hydrogen has atomic number 1, helium has 2, lithium 3, boron 4, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, and then potassium 19, and finally calcium 20. Now, having known this, first thing you need to do is to make a column. Divide the column into 8 groups. 8. Number them 1, 2, 3, 4, 5, 6, 7, 8. In some textbooks and online, you see different kinds of versions of periodic table. Don't be discouraged. You may see group O instead of group 8. It's still very correct. I'm going to tell you why. Now, having been able to distinguish and place your group into 8, put hydrogen in group 1, then put helium in group 8 on the same column, on the same horizontal level. Then after that, place your lithium to neon horizontally. Just place them: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, just horizontally. Then start with the next element: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now, having done this, this will now allow you to be able to now appreciate the beauty of this arrangement of the periodic table. This is why periodic table now is very necessary. Now, having arranged those elements together there, now you see that lithium, sodium, and potassium, when you begin to analyze the electronic configuration, you will discover that all of them have one electron in their valence shell. That is the beauty of the arrangement. That's why I told you that elements in the periodic table are arranged strategically based on the number, the atomic number. And then you know the atomic number is having a very close proximity with the number of protons in their atom. You know, atom has subparticles: the proton, the neutron, and the electron. Proton is positively charged, of course. Electron is negatively charged, while neutron is neutral. So we take the number of proton and then we use it as a basis of the arrangement, which becomes the atomic number of each element in the periodic table. So now, having checked this, having arranged this, then you see that lithium, sodium, potassium, They are in group 1 because they have one valence electron. Beryllium, magnesium, and calcium, they are in group 2 because they have 2 electrons in their valence shell. Like that, boron and aluminium 3, carbon and silicon 4, nitrogen and phosphorus 5, oxygen and sulfur 6, fluorine and chlorine, which are the halogens 7, and helium, neon, and argon, they are arranged in group 8, which are called the noble gases. Now, all these are stratified. Group 1 are called alkaline metals. Group 2 are called alkaline earth metals. Group 3 are the metalloid. Go like that. When you read group 6, non-metal. Group 7, the halogen, and group 8, the noble gases. When we begin to look at each of the characteristics of this group, when we get to family of elements, we are going to extensively deal with the characteristics of each of this group, each of these families, because they have become a family because they have unique characteristics. They have unique features. Now, group 1, you see lithium, sodium, having the same number of electrons in the outermost shell. They become family because they share characteristics, they share properties together. So we're going to deal with that when we begin to analyze each after the other. Now, one thing is very paramount. Please take note of this. I've seen this in SSC questions, in JAM questions, and students sometimes are not paying a close attention to this part. Elements in group 1 and 2, they are called S block. Group 1, group 2, I'm going to show you shortly after this slide. Group 1 and 2, they are called S block elements. Then elements in group 3 and in group 8, they are called P block elements. Now, between group 2 and group 3, there are elements that are arranged accordingly. We call them transition metals. Then you can see some textbooks on your exam, they call D block element. It's the same thing. And I have explained to you why we call them D block element. Then outside that, we have the inert transistors, metals. They are called antinide and nantinide. We call them F block elements. So by way of disintegration and by way of stratification, we have the S block elements, group 1 and 2. We have the P block element, group 3 and group 8. Then we have the transition element, D block, and finally we have the F block element. That's awesome. So now, if you look at the first group, which is group 1, they are called metals. Alkaline metal. Now, this is very important. You need to pay attention here. There are about 98 naturally occurring elements, and 70 of them are metals, and they have several properties in common. Generally metals are malleable. We're going to go, why are they malleable? They can be bent into different shapes without breaking. We're going to, these are pragmatically the physical properties. As you look at copper, look at lead, look at tin, look at nickel, look at steel, look at zinc. All of them are malleable. They are strong because this is their physical properties. And then when you look at them further, you see silver, iron, gold. These are all metals, and then they are ductile. They can be stretched into different tin and wire. They also conduct electricity. And if you look at them, look at gold, very shining appearance. They use gold to make jewelries and all kind of things. This is the fundamental. You need to have this understanding. By the time we begin to go into details, how does metal, how do they react? What do they react with? How do they produce oxygen gas? How is hydrogen gas produced? These are things we are going to be referring to allow you have the comprehensive knowledge of it. Now, after the metal, the metals can be the group 1 and group 2. Those two groups, they are metals. Now, group 3 are metal. These elements are known as semi-metal, and it's very simple. Why do they call them metal? Very simple. It's just because they have both metallic and non-metallic properties. That is, look at silicon. Let's take silicon for example. In group 3 we have boron, and if you look at it very closely, silicon, germanium, the arsenic, the antimony, and the rest of them. Now let's take one of them. Let's look at one of them critically. The silicon. I'm sure you know silicon. Silicon, it have a very, it's like a shiny metal. but it does not conduct heat and electricity. It does not now when you get to transition element, they will tell you transition element has variable oxidation state. Not all of them. It's not chemically sound, it's not chemically correct to say that all transition elements have variable oxidation state. Not all of them. So when we get to transition element, I'm going to tell you those that have variable oxidation state and those that does not. Now silicon is brittle like. So you can see number one is shiny but does not conduct electricity. Number two, it has a kind of is a brittle like non-metal, which is a semiconductor. So it's used in computer and other electronic device. So let's move on. Generally, I'm trying to analyze each of the groups in the periodic table first. When we are done with the analysis, the arrangements, then we can now go into the properties, both physical and chemical properties of each of these groups. So non-metal, generally, when you look at from the group 4, group 5, group 6, group 7, they are all non-metals. Now generally, let's have a review of them. Carbon, sulfur, phosphorus, all of them are non-metal. Now there are peculiar characteristics that all of them have, regardless of their group or their period. They are all non-metal. But we are going to further distinguish between chemistry of carbon, chemistry of sulfur, chemistry of phosphorus, and we are going to analyze each of their characteristics. But generally, non-metals are found at the right hand of the periodic table. The metals are found at the left hand, while the non-metals are at the right hand of the periodic table. So some of their common characteristics or features or properties are: one, they are brittle and they break easily. When you bend them, you can't really form shape out of them. They do not conduct heat or electricity. They look very dull, and they do not have a shining appearance. Look at sulfur, look at bromine, look at oxygen, look at carbon. They are generally dull and not conducting electricity. Now, this is what I'm trying to explain to you. Look at it very critically. Look at this arrow. This is group 1. This is group 2. Now, between group 2 and group 3, you see these elements. Look at all these elements. They are called D block elements. And I told you they are called D block elements because their valence electron, when during electronic configuration, enter into the D block degenerate orbital. Not just the orbital, degenerate orbital. Because when we get to electronic configuration, I'm going to show you the principle that governs the placement of electron in the orbital. Now, let's go ahead. Look at this. These are transition metals. I want you to look at it very critically. These transition metals, starting from the first line, the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, all of them are arranged according to the atomic number, according to the number of shell in the period, and according to the number of electrons in the valence shell in the group. So let me clarify this and get it very direct. One, when you see element in the same period horizontally, they are arranged based on the number of shell they have. But when you see them arranged vertically, they are arranged based on what? The atomic number and the number of electron in their valence shell. The number of electron in their valence shell. So transition metals generally are a group of metals in the middle section of period between 2 and 3, and all the transition metals have different properties. They are shining metals. Some of them they exhibit color. Some of them, most of them, the gray color, except for gold and copper. Now listen, if you say all transition metals are colored, what kind of color? Because you need to ask yourself. In chemistry, there are some things we don't generalize. We have to know what for what. Now we have to know what color do they exhibit, and which of the elements are not exhibiting the color as the other, the same color that other metals are, carrying. So we need to understand that except for gold and copper, most of the other transition elements, they are shining metal. They have metallic gray color. It's very important you understand that. Of course, transition metal conduct electricity. They have high melting point. Most of them form color compound, except for zinc and scandium. This is where you need to also pay attention. Zinc and scandium, they have a unique property among all other transition metals. So when we get to the analysis of the chemical properties of transition metals, we are going to delve more into why zinc and scandium have a different, unique property apart from some other transition metals. So some transition metals have more than one valency. Now, when you say all of them have valency, what is their valency? Like iron has valency of 2 and 3. Why? We need to explain this when we go further in our class. So let me quickly take you to the history of periodic table. This is very important. I intentionally skip this part because I want to come over to explain this. There have been many controversy in chemistry over the years, and many people are saying, oh, this is the scientist that helped in arrangement of periodic table and this, and giving credit to these scientists. But I want to say that history has recorded that in 1869, a Russian chemist by name Dmitry Mendeleev, he was the one that started the development of the periodic table. He investigated different elements and then he arranged them according to their chemical property by atomic mass. Please listen here. I've seen these questions in so many, past WAEC question, JAM and NECO and what have you. And you see students making mistake, not being able to know. Now, I say that the arrangement is based on their chemical properties and then by the atomic mass. This is what we're going to need to go into before we begin to delve into their properties. You need to know the atomic mass of each of these elements. Like oxygen has atomic mass of, what's the atomic mass of oxygen? It's 16. When you talk about sodium, 23. When you talk about carbon, is 12. When you talk about calcium, is 40. So we are going to look at this atomic mass first. You must know, and I'm going to tell you the relationship between atomic mass and atomic number, so you don't make mistake. But now, for the purpose of the history, we are looking at the man, the very Russian chemist that that went ahead to investigate elements and arrange them according to the chemical property. Now, I must say that the history of the periodic table reflects over a century of growth in the understanding of the chemical properties. This culminates the publication of the first actual periodic table, and the first one was done by Dmitry Mendeleev in 1869. So make no mistake about it. However, while Mendeleev was building up this structure, he gave some spaces because he was unable to discover all the known elements, at that time, because he knew that there may be need to synthesize some other elements. So when he began to arrange these elements in the periodic table, he gave room for the element that may be discovered alongside. So, but there's a man called Anthony Lawrence. This man also assisted. He took the work from Mendeleev, and after discovery of certain elements, he also helped in the development of the structured so-called modern periodic table that we have today. So I want to quickly go to summary now. What is this lesson all about? Primarily, you need to know, number one, that the periodic table is arranged based on the atomic number, and number two, you also need to know that they are organized and arranged based on their chemical properties. And then I have told you that the atomic number has a link with the number of protons in the atomic nucleus. So thank you very much. Let's quickly review our exam guide questions before we close this lesson. Now, looking at this, now the first question says, which of the following metals in the group 1 has the highest ionization energy? Now, when you look at the arrangement of the elements in the periodic table, You see, ionization energy is the ability of an atom to ionize or give away the outermost shell, outermost electron, in order for such element to participate in chemical combination. Now, we have on the list A, lithium. 2, we have rubidium, we have sodium, and we have calcium. So, looking at this, number 1, which one has the highest ionization energy? If you look at it, lithium will have 1 on the outermost shell, like that. When you look at it, when you look at sodium, it will also have 1, but lithium come first before sodium. So lithium is the correct answer. Number 2, which of the following halogen is the most reactive? If you look at the arrangement of the halogen in the periodic table, you will discover that goes from fluorine, chlorine, bromine, iodine, astatine. So which of the following halogen is the most reactive? So the most reactive is fluorine, because fluorine comes first before other halogen. Number 3, elements in the same period in the periodic table have the same number of shell, atomic number, chemical properties, physical properties. You know, it's talking about in same period. So they have the same number of shell. A is correct. The next question, looking at this very critically, just like I taught you how to arrange the first 20 elements in the periodic table, you will see that we have group 1 to group 8. Now, look at it very quickly. Look at the question. Which of the letter indicate element which exists as diatomic gases? Now, when you look at this element, you have A, C, D, you have B, A, B, C, D, E, F, G. Now, A is hydrogen, B is what? Helium. And then when you look at it, you have C as beryllium. Then you go ahead, still looking at the first line and the second line. If you have helium, you have lithium, you have beryllium, boron, carbon. It means D is carbon. Then when you go nitrogen, oxygen, fluorine, neon, sodium, it means E is sodium. Then you go ahead. Like now, the question is which of the letter indicate which of the letter indicate element which exists as diatomic gas? B and G was A. That is A, helium, hydrogen, and G, the last element there. Then when you look at C and F, you discover that both of them are not diatomic. When you look at C and A, you notice that beryllium is not the atomic gas. So the right answer here, you have hydrogen. When you see hydrogen is a diatomic gas, and then when you look at fluorine, you also notice that E is also a diatomic gas. So A and F is correct.